The prehistory of the gravitational astronomy began with a theoretical concept. The first non-relativistic estimations of light deflection near a massive body were done by Pierre-Simon Laplace and Johann von Zollner. During his stay in Prague, Einstein supposed that deflected rays can enhance the brightness of the image of a star when they pass by another star nearer to the observer. The probability of such an exactly linear alignment of two stars and observer seemed to Einstein and his colleague Erwin Freundlich totally negligible. However, the idea excited many other astronomers and physicists. Until 1979, when three astronomers, Walsh, Carswell, and Wyman, finally discovered gravitational lenses. To be exact, they discovered two radio images of the quasar and then observed the object with a telescope. According to the spectrum, they determined the distances from us to the gravitational lens, galaxy, and to the quasar. A radical new style of observing started. But why so late after the theory? Here are three remarks concerning the observing of the images. The geometry of the image indicates the structure of a gravitational field of the intermediate object. Without gravitational lensing, no observation of the background field would be possible. Strong lensing enables observing of multiple images of a source. Weak lensing enables observing of deformations of the image of a source. The opposite effect, microlensing, I will mention later when talking about František Link. It raises specific epistemological questions. What does it mean for exact sciences if some objects can be observed only through their deformed images? Are there any consequences for validation and description of those objects? Based on further development of the gravitational astronomy, it seems that observing of many more objects is possible, not only quasars, but also galaxies, clusters of galaxies, crash of galaxies, cosmic shear effect. However, more and more experimental observations influence the qualification of gravitational astronomy as a new scientific discipline. Or was the verification based on theoretical conceptions, or rather on plenty of empirical data from observations? Were new observing programs stimulated by a successful empirical experiment, or a skeptical comment on unverified theory? What I want to say is this. After Einstein published The Principle of Equivalence, 1911, and the Theory of General Relativity, the idea excited some astronomers and physicists, but it took several years before Einstein published the lensing equation, 1936. Why so many years afterwards? Was the mathematical theory so abstract and bold that nobody could imagine such an observation? Or maybe due to Einstein's comment, there is no great chance of observing this phenomenon, end of quotation. Or did it challenge astronomers and physicists to intuitively deduce a new paradigm? In our contribution, we would like to focus on the role of Czech astronomer František Link. He created a photometric theory of lunar eclipses, 1933, and observed various optical effects in atmosphere. In 1936, he was appointed the assistant professor and for a short time became the first director of the Central Astronomical Institute in Czechoslovakia. Because of personal struggles and his egoistic manners, he was let go from the director's post and led only the department of the high atmosphere at the institute. Since 1945, he had many contributions and different observations and published almost 200 papers, a few respectable monographies, and had many citations and contacts abroad. In 1967-68, he gave the host lectures at the Faculté des Sciences de Paris, and thanks to it, finished his life work and published the monograph eclipse phenomena in astronomy. At that time, he left Czechoslovakia and lived in Paris, where he stayed until his death. This book, appreciated by many astronomers and physicists, as evident from his correspondence in our archive, is divided into 7 chapters. For us, the last chapter is the most important. At the beginning, František Link clarified the theory of the single ray deflection and explained the dioptrics, how and when the observer sees 2 images. Link concentrated on the changing perspective of the observer and derived the equations for illumination by stellar disk in comparison with light intensity of his observations of lunar eclipses, and then derived the equations for gravitational occultation. He also reconsidered the density of the deflecting star and its distance from the Earth. With the aid of his photometrical theory, he drew the images of the star during its gravitational occultation and published first diagram. František Link emphasized his theory, but of course he mentioned investigations by other astronomers and was quite amazed by a paper by a Russian astronomer Tikhov, which was based rather on the Newtonian deflection. In conclusion, Link emphasized the phenomena must be examined with care from both theoretical and observational viewpoints. As the monograph documents, Link built his whole career on his photometric theory of lunar eclipses. He did first observation and measuring in 1931 and published the results in a Czech journal, 1933. He undertook a calculation of positions of both images of the source and derived a relationship for amplification of the illumination of the source by lens, 2 articles in 1936, 1937. The angle for the deflection of the ray was computed as the relativistic deflection of light. In 1936, during his stay in France, František Link published his calculation of photometric effect in French journal. A few months earlier, then Einstein's article on the same topic appeared in Science on 4th December 1936. In his monograph, František Link explained the history of Einstein's photometrical effect as a curiosity. They both didn't know about each other's calculation. For Link, I quote, "It was a natural extension of our formula, of Y formula, giving the attenuation of light by refraction to the gravitational deflection." End of quotation. According to Link, Einstein's paper was actually an answer to his correspondent Rudi Mandl. Einstein also gave the formula for the critical distance and for the total increase of the illumination, but was skeptical about the usefulness of the phenomenon in astronomical practice. End of quotation. In 1969, Link suggested that Einstein's remark slowed down the astronomical observing. One thing is clear. At the very beginning, gravitational lenses were a strictly theoretical example of the photometric consequences of the deflection of light in gravitational field. More people were thinking about gravitational lenses effect in the 30s, and for illumination, they were looking for an ideal alignment of all 3 objects. The micro lenses, where the intermediate body is a star from our galaxy, were found in 1989 on the image of quasar QSO 223 plus 0305. Since that time, hundreds of such events have been found. Some examples: the transient brightenings for a couple of days due to the motion of the intermediate star were observed thanks to projects like ALGO or MOA. As of April 2020, 89 exoplanets around the intermediate stars have been detected from irregularities of gravitational field caused by the orbiting planet. Another application of microlensing was the project MECO, an observational search for dark matter around our galaxy. Since 2017, the new generation Korean microlensing telescope network has been continuing the survey, and W1st NASA space mission is planned for around 2024. Conclusion and epistemological questions. František Link was really one of the pioneers. Also, when he in 1969 emphasized the phenomena, I quote, must be examined with care from both theoretical and observational viewpoints, end of quotation. This opens a question of the relationship between theoretical notions and empirical experience. This relationship is somewhat similar to an older argument between John Mill and William Webber about the origin of scientific notions, which are formed by evaluation of experience. Mill supported the induction theory, generalization of experience, while Webber was an advocate of the colligation theory, unification of apparently independent facts. The Czech historian and astronomer Zdeněk Horský in the 70s focused on the epistemology of science and the history of cosmology. In 1979, he explained in his popular book, The Universe, in Czech Vesmír, how the general theory of relativity was gradually confirmed by some observations. Horský emphasized, however, that too many scientists, the theory seemed to be forming empirical laws based on a large number of individual experiences. But this leads to a schematic perception of theory as cataloging work and an induction process. During the development of exact scientists, it happened that scientists were inspired by their experience, but using their intuition, they deduced a new theory. And with Zdeněk Horský. This is why the English scientist William Webber introduced the category of colligation, which is a true unification of phenomena under one notion. A precious connection between these phenomena is made by a scientist in an act of the intellect. In our case, I would say František Link was convinced by Einstein's refraction of light that he combined a few of his observations and came up with a theory of lunar eclipses. This is why he stressed the examination with care from both theoretical and observational viewpoints. In other words, a change of paradigm took place. Link predicted that the microlensing effect would be easier to observe in crowded fields or in galaxies. Observations confirmed it in the 90s. Still, we cannot say that František Link outran Albert Einstein. Edited Einstein's diary from years 1910-1914 shows that he drew the gravitational lens and quotations in April 1912, probably on his journey from Prague to Berlin. But why didn't Einstein calculate and publish the equation until 1936? And why did he do so with a skeptical comment about its usefulness? In 1936, a poor Czechoslovak engineer, Rudy Mandl, came in the USA to the editors of Science newsletter with a proposal on how to calculate gravitational lensing. I quote, "You see, the light from a distant star will be bent as it passes the nearer star, and the effect will be a great brightening that anyone can see with a small telescope." End of quotation. The editor gave him money to go to visit Einstein in Princeton on the 17th of April, 1936. Einstein was rather skeptical about the passion of an amateur scientist from Czechoslovakia. After the editor's reminder, He published an article in Science with this skeptical remark. I quote, "Some time ago, R.W. Mundell paid me a visit and asked me to publish the results of a little calculation which I have made at his request. There is no great chance of observing this phenomenon." End of quotation. Yes, Mundell was an obscure amateur scholar, but using his intuition, he created a bold but true idea. František Link was a successful astronomer, and using his intuition, he created a great theory. They both didn't know each other. Thank you for attention.
Thank you, Thomas, for this very interesting presentation about this about microlatensing and the Czech contribution. So I see there is a question on the chat from Juan Andres Leon, and he asks, was there any relationship between Link and Erwin Freundlich, personal and intellectual? Freundlich was briefly in Prague until the German annexation in 1938. Are you aware of some link between some connection? Oh, okay. This is okay. This is something that can be probably deepened, but.
From the research in František Link archive collection, I didn't find any contacts between Freundlich and František Link. František Link, until 1936, he was the secondary school teacher and astronomer at the observatory only as work on contract. So I'm also not sure how many contacts Freundlich have with Czech astronomers, and maybe rather with German physicists in Prague in 20s and 30s.
Thank you, Thomas. I see here another question. What was from Roberto Lalli, who asks, what was the relationship between Einstein's stay in Prague and the interest in general relativity by Link and other scientists in Prague? I can't hear you.
Yes. Please, there were only few physicists that in Czechoslovakia or in the Bohemia before the First World War. Only few, I suppose, 4 persons who were convinced that the general relativity is correct, and the other not. So that there one can say that Link understood well what the general relativity means, and I suppose he was delighted to have such a nice theory. But to the question, to the last question, in Prague there were 2 universities: the Czech Charles University and the German Deutsche Universität zu Prague. And Freundlich was active at the German university, but they knew each other. I mean, Link and Freundlich, but the contacts were not much intensive.
Oh, thank you. And so I think that Roberto, okay, and then there's another question, sorry, from Scott Walter, who asked if there was some contact of a Link in France. Did he have some contract? Do you know if he had some contacts in France?
Yeah, actually, František Link emigrated from Czechoslovakia at first to Germany, and he finished his monograph, published it, and then he got a position in Paris at the Institut d'Astrophysique. So most of his contacts were connected to people at this institute, and actually with astronomers who were observing the high atmosphere. And František Link lived and worked in Paris until his death. What we don't know if František Link in 1979, if he mentioned the observation of the first quasar. We have no sources, no remarks to this patient.
Thank you. And I don't see other questions, so I make one of my own. So you mentioned all these very far-sightedness of these Czech scientists, but also not scientists, as the engineer you said, Mandel. But what happened later? Can you give some brief insight of the investigation and lensing in Czechoslovakia later? I mean, after the war.
No.
Or I mean, it's just to.
This is hard to say because there were only again only few physicists from the Institute of Theoretical Physics at the Faculty of Mathematics and Physics, and one person in Brno at the Masaryk University, who were able to create something new in the general relativity. The names are Professor Bičák in Prague and Professor Novotný in Brno.
So, in some sense, the tradition was established of this kind of studies in Czechoslovakia later, starting from these very early works by Link. There was some kind of history that went on. I see that there is. Thank you. I see that there